Hello students, let us solve a beautiful question, a beautiful problem from GATE 2023, and it's a part of actually atomic physics. In that question they have given that two non-identical spin half particle and their spin product is provided, and that spin product is or spin product state that is mentioned 1 by 2 plus 1 by 2, 1 by 2 minus 1 by 2. This is the spin product of two non-identical. This is a spin product of two non-identical particle. Okay, so I can mention like you have a two non-identical particle A and B, and the spin value S on is half, and the Z component SZ on. The spin of second particle that will be S2 with Z component SZ2. Also, it is mentioned the Hamiltonian of the system. They have given the Hamiltonian of the system, and that is given as 4 lambda by h cross square s on dot s2. Lambda is constant, h cross is that is a reduced Planck constant, and s on is the spin value of particle on, and s2 is the spin value of particle 2. So what you have to calculate? You have to calculate the expectation value of Hamiltonian for this state. For this state, you have to calculate. Now, it's an interesting question because you have to apply Cleb's Gordon coefficient to solve this question. Okay. So according to CG coefficient, if you calculate the CG coefficient for this state I can write. This state I can write. You have a two state. I mean spin product state for particle A and particle B. This is S on with SZ on, S2 with SZ2. Right? This thing I can write. If I calculate that CG coefficient, I'll get 1 by root 2, 0, 0. The net spin and this is net SZ. And you'll have 1 by root 2 on and 0. So net spin and net SZ. So this state is superposition or made up of superposition of two states having net spin 0 and net spin on with equal probability. Now from that given Hamiltonian, H was given it was like 4 lambda by h cross square s on dot s2. Okay. So to calculate that expectation value, we have to calculate that expectation value of s1 dot s2. Okay, and we know how to calculate because net spin s, that will be s1 plus s2, and if I make square both sides now, I'll get s1 dot s2, and that will be s square minus s1 square minus s2 square divided by 2. So simple algebra is there. Now if I calculate the expectation value of s1 dot s2, then I'll get s square expectation value of s square, that is nothing but s into s plus 1. I'll write h cross square later because it will be common, and then we'll have s1 plus 1, okay, minus s2 plus 1, and then you have h cross square and divide by 2. You have a two spin system. So that net spin can be, you have a two spin s1 and that is half, s2 that is also half. So net is s. This net s will be how much? It can be a half plus a half. or it can be half minus half. So it can be on or 0. Okay. Now if I calculate that expectation value, if I calculate that expectation value of S1 dot S2 for S equals to 1. Okay. If I calculate that S1 dot S2 for S equals to 1, I'll get that will be on into 1 plus 1, that will be 2 minus S1 is how much? That is on. So on this factor will give you on by 2 into 1 by 2 plus 1, that will be 3 by 4. Again S2 is again half, so it will give you 3 by 4 and divide by 2 and you have h cross square. So we solve it, you'll basically get h cross square by 4. And similarly, if you calculate that S1 dot expectation value of S1 dot S2 for S equals to 0, net spin 0. So now in place of S you have to substitute 0, but S1 and S2 again you have half value. So first term will be 0 and second and third term will be minus 3 by 4 and you have a 2 factor divide. And of course you have h cross square. And that will give you minus 3 by 4 h cross square. So this is the expectation value of S1 dot S2 for two different states, S equals to 1 and S equals to 0. Okay, now if I calculate that expectation value of h, okay, so I have to use this formula, sum over probability of ith state and with energy of ith state. And we see that probability of S equals to 1 and S equals to 0, both are equally probable, that is 50% or 1 by 2. So if I apply this, they are equally probable, then I'll get the value. First of all, this probability will be common 1 by 2, and also this factor will be common, that 4 lambda by h cross square. It was given in Hamiltonian. This will be common. Okay. So 1 by 2 that will be common, and 4 by lambda square h cross square that is given. And then I'll write that energy, that will be h cross square by 4 minus 3 by 4 h cross square. Okay. So it means 4 lambda by h cross square into this, if you solve, you'll basically get minus h cross square by 4. So this 4 will be cancelled, h cross square will be cancelled, and you will end up with minus lambda. So this will be the expectation value of h. This will be the expectation value of h. Okay, thank you.